Moving on to block syntax. In this stage, we need to add block syntax to our interpreter. Blocks are enclosed in curly braces and are used to group statements together. Actually, not just statements, they are grouping variable declarations as well. And more importantly, variable declarations inside of a scope go into a different environment. In our interpreter, we have an environment, right? Let me show that. Interpreter. And we have an environment. So, but when we enter into another scope, we can't declare variables in that environment. If we do that, those variables will be accessible even outside of the scope, which is something we don't want. So when the control flow enters into a block, we need to create another object of environment, env2 in this case, and we will declare variables in this. And when the control flow goes out of scope, we will remove this environment. We will destroy this environment. And then the variables declared in that scope will not be accessible outside of the scope. That's how we're going to implement it. And if let's suppose there is a variable called a in the outside scope and there is a variable named a in the inside scope, then when we try to access the variable, we need to make sure that we are not accessing this variable. This should not be accessed when accessing a inside of the scope. We need to access this one. What we'll do is, for now, we will create another object of environment and then we will override the environment, the class level environment. And when we come out of the scope, we will replace the references. We will swap out the references and then the main environment will start pointing to env again. So when the control flow enters into a scope, we have a variable env. So before entering into the scope, the env variable refers to this. But when we enter into the scope, I will store a reference to this env in a temporary variable and will make the env point to this inside environment. And then when we come out of the scope, I will swap out the reference to the outer env again. I'll show you what that means when we get to coding it. Anyways, this is valid code. This is valid in Java as well. We can start scopes anywhere. And matter of fact, these scopes are going to be a building block to other statements like if statements and for statements and while statements. So it's a lower level construct than an if and a for statements, and it can have declarations inside of it, as you can see right here. So to do that, to handle this, we need to make changes to our context free grammar. We need to add syntax for it in the grammar and then we need to parse it. So let's do that. This is what our context free grammar looks like currently. So we will add block syntax to it. Block syntax. Like I told you, a block statement will have declarations inside of it. So let's see what a block looks like first, and then we'll decide where to put it. So a block statement starts with a curly brace, and then it can have a list of declarations inside of it. Declaration and multiple, and then it ends with a curly brace as well. That's what a declaration looks like. And a block is a type of a statement. We are right here, we are processing statements, so that should be a hint. A block is a type of a statement. And let me put it right here. We need it to be a lower level construct, and there is the only thing lower than it is a declaration, and it's definitely not a declaration. So the next thing is a statement. So we'll start processing blocks from statement. We know we are at a block when we encounter curly braces. That's how we will know that we are at a block statement, and we can start parsing it. So to do that, we need to first add this to our statements. We have some a package of statements, so we need to add it there. So I'll create a new class and I'll call it block, and it needs to extend our statement. And then we need to implement the method, and in the visitor we need to create a new method dot visit block. So let me call it statement as well, visit block statement, and I'll call it with this. So let's create this method in the interface. We need to implement it in the implementation, but what else does a block contain? Looking at the context free grammar, I can tell you that it contains a list of declarations. So it needs to have a list of declarations. So public final list declarations for article. Declarations. Uh, let's import the list and let's create a constructor for it. That should suffice. After this, we have added the node that we need to add to our AST. So let's construct the AST. Let's add it to our parser. In our parser, looking at the rule, we added it in a statement. So let's go to statement, control F, statement, and declaration. Here is the statement. Let's go to statement. So as you can see, if we match the current token to be print, in that case, we parse a print statement. Can you guess how are we supposed to know if we are parsing a block? Like I told you, a block starts with a curly brace and we have a token for it already. So we will match for it, match current token to be a left brace. If that is the case, then I need to return a new, so right now what we are doing is, if we were to go by how we have been writing our parser, I should do this. But that's not what I will do. What I will do is I will create a method, and this method does not return the object of block. Why is that? Because I told you a block is going to be a building block, a block statement is going to be a building block for other statements like the if and for. So I want to create a method that only parses the underlying declarations for me and returns a list of declarations, and so I can create a new block out of it. So that method will be helpful in parsing if statements and for statements later on. So maybe it doesn't make sense, a lot of sense right now, but it will in the future when we come to if and for statements and while statements. This block will be very helpful. So that's why I'm creating it like so, new block, and inside of it I will create this block method. Now this block method is only going to return a list of declarations. So I want to create this method, private list of, oh wait a second guys, article statement, article declaration, article cannot be a statement. Statement can be a statement. So I made a mistake. It should not be vardecal, it should be a statement. Since a vardecal implements statement as well, if you were to go to a vardecal and you see that it implements statement, that's why we need to make it statement, because this statement can then hold a reference to vardecal as well as any other statements that we create. It needs to be statement, and it needs to be a list of statement and block. And inside of this method, like I told you, we're going to return a list of statements. List of statement, and I should also make it statements, new array list, and let's just return it, statements. And now we need to parse those statements and insert them into this list. So since there can be many multiple statements, we need to parse them in a loop till there are. And how do we know we have come to the end of the block? We will only come to the end of the block when we hit the right brace. So let's check for it. Check current type, and it should be a right brace. So till it's not a right brace, I can continue parsing. But it may be the case that the person who wrote the code wrote it incorrectly and they're not actually closing the scope. In that case, I should also check if my code has come to the end. And I can only continue parsing while I'm not at the end, is at end. In this case, I need to parse a new declaration. So statement stmt equal to declaration, and I can then insert it into the list of statements. Statements.add stmt, and right here we need to do something else. That is, let me show you what that is. Syntactic errors. As you can see, there are some errors that are expected of us. Similarly, if a right brace is not encountered, if the person who wrote the code wrote only this much, in that case we should let the person know that they wrote incorrect code. So we can do that by checking for a right brace. So if the control flow comes here, then we are expecting there to be a right brace, and then if it is not there, then we need to throw an error. So we have a method for it already, and that is this consume method, and it checks for right brace and it will throw the error that we need to throw. Let me just copy the error, because if we do not throw this exact error, it will cause issues. So I would implore you to copy it as well, or maybe just don't make mistakes while typing out. Anyways, that's it for block. That is creating the list of statements for us and returning it. And then we create a new object of block right here. We created it this way and not created the object of block right here, because this block method is going to be later on used for creating if statements and for statements and while statements and classes as well. So it will be very helpful later on, because we don't want to create an object of block right then and there. So we will have the liberty to create object of block on our own. Anyways, that's it for the parser. But now, since you remember we added it to a statement visitor, what do you think we need to update? We need to update the interpreter. So let's implement the methods. Before we go on implementing this method, let me remove this just so we don't forget it. Like I showed you, this diagram, we need a way to be able to store references to this outer environment and then replace them with this environment and so on. The actual environment data structure actually is a linked hash map. So this hash map stores a reference to the inside one. Sorry, actually the opposite. The inside hash map stores a reference to the outside hash map as well. And that's the actual data structure implementation. If you were to go and look at it, maybe I can bring it up for you. Environment data structure compiler. So it's an actual data structure. I'm not sure. Maybe I'll have to look it up. Maybe if I find it, I'll link it down in the video. But in any case, the inside environment needs to store a reference to the outside environment. Why is that the case? Because let's say A did not exist here. And if we were referencing A inside of the scope, we will have to find the A in the outside scope as well. That is why the inside scope needs to have a reference to the outside scope. And then this outside scope will have a reference to the scope outside of it. Like so. And if this A did not exist in this environment, let's suppose it existed in this, and we were in this block right here, in this block statement right here, if we were to ever reference a variable called A, that's a bad color, sorry guys. If we were to ever reference a variable called A, what we need to do is, we first need to check if this A exists in this environment. If it does, well and good, return. If it doesn't, then we need to go up one step and then check the variable if it exists in this environment. If it does, very well, return. But if it doesn't, then we need to go to the environment outside of it. So it's a linked hash map data structure. And since the A exists in this, we need to retrieve the value from this hash map and then return it. So we need to make some changes to our data structure. Our data structure looks like this. It needs to have a reference to the outside environment. It's a linked hash map, so I need to store a reference of the outer environment. So I will call that the enclosing environment. So public final environment enclosing. And then I need to create some constructors. So let me create a constructor for it. And then I need an empty constructor as well for the base scope that doesn't have any enclosing environment. For that environment will require a constructor that is not taking any parameters, and for that the enclosing environment should be equal to null. So I will do that, and enclosing should be null. And like I told you, if the variable does not exist in this environment, we need to check the outer environment, and we can do that recursively. So we will do that right here. So if the control will only come here if we do not find the variable in the current hash map. So right here, if enclosing is not null, then I can recursively check on the outer enclosing environment. So return enclosing dot get, and I will send it the name. Right? Similarly, the same thing goes for assigning variables. Not for defining variables. For defining, we always define in the current environment. But for assigning variable, if a variable, let me show that to you. So this is a scope, and we are able to create variables right here, and we are able to assign them new values right here. So in assigning, if we do not find it in the current scope, then it may be existing in the outer scope. So if it is existing in the outer scope, I need to update the variable in the outer scope. So I will do the same thing here. If enclosing is not equal to null, in that case, what I will do is I will return enclosing dot assign, and I will send it the same variables value, and it doesn't return anything. We just need to call it. But then we do not want to throw this error. So what I'll do is, and then return from here. I hope that makes sense. So now we can finally go ahead and implement the interpreter and visit the block statement. In the block statement, like I told you, it's just a list of declarations. And like I told you, in our parser, we are parsing list of declarations and then creating a block out of it. And I told you this block will be used for if and for statements as well. So this differentiation between creating and parsing, we need to do something similar in the interpreter as well. So this is a visit block statement, and this block is just a list of declarations, right? What I'll do is I will create another method that executes a list of declarations. And then that method can also be used for statements, if statements, while statements, and by the same logic that we used right here to bring this creation of block outside of it. By that same logic, we are bringing the logic of execution outside of the statement so that it can be reused later on. So what I'll do is I'll create a new method called execute block, and I will send it the statements block dot statements. And like I told you, whenever we start a new block, in that case, we are creating a new scope. And what do we need to do for a new scope? We need a new environment for every scope that we enter. For every scope that we enter, we need to create a new environment variable, and that scope should only work on that environment. So I will create the new environment right here, new environment, and I will pass it the enclosing variable, enclosing environment into it. And this execute block will be responsible for managing the references to the environment. What I'll do is I will create a environment and I will store it the current enclosing environment into it. All right. And then I will create an object that will be the result of this execution. This is not actually required, but I am doing it because I like it. You can actually script this result object and it can be void, but I don't like that. I like the way I do stuff. What I'm doing is for any block, I will return the value of the last statement, the resultant value of the last statement of the block. So this a equal to 2 will result in 2, and then the block will also result in 2. That's what I want. So that I will store in result, and from here I will return the result. All right. Now I told you that we need to manage the references, and a great place to do that is in the finally block. In the finally block, I want to swap out the I want to bring the environment back. I want to bring the outer environment back. So that can be done with this .env equal to previous, the reference we just stored right here. Because we need to do this because inside of this try block, what I'm going to do is I'm going to shadow the outer environment. This dot environment is going to be equal to, I will call this scoped environment, scoped env. So whenever we try to execute a block, we update this environment. And then when we come to the end of the block, we bring the environment back like so. All right. Now that we have shadowed the outer environment with the new scoped environment, I can simply execute all the statements that are in the list. So statement stmt in statements, I just need to execute them. And that's going to be quite simple. Executing them will be stmt dot accept this. But I told you I want to return the resultant value of the last statement, and that can be handled like so. So I think that's it for the execute block. Let me try and push it and see if it works. Git add git commit -m, and let me give it a good message. Block syntax and git push. All right, all the tests passed, and now we have added block syntax to our programming language. Matter of fact, since we handled this scope thing, we have also passed the next stage. Let's see if the tests for that work as well. Let's wait for it. And I think it should work. And it certainly does. So we have passed two stages in this video, and we'll be starting with control flow statements from the next one. So that's it for this video. See you in the next one.